Hello everyone, myself Hans. Today we are going to solve the given problem from topic partial differentiation. Question is given here. If v is equal to a into t to the power of minus 1 by 2 and exponent of minus of x square upon 4a squared into t, then so that a square into del 2v upon del x square is equal to del v upon del t. Let's solve the problem here. Given v is equal to a into t to the power of minus 1 by 2, and here exponent is written as e to the power of minus of x square upon 4a square into t. Let this equation 1, and we have to show that here a square into del 2v upon del x square is equal to del v upon del t. So differentiating partially equation 1 with respect to t, we get del v upon del t. When we have to differentiating equation 1 with respect to t, treating x as a constant, this gives a is taking outside here, a is constant already, and we have to differentiating with respect to t and taking x as a constant. So t to the power of minus 1 by 2 is taking, this is first function and this is second function. First function is outside t to the power of minus 1 by 2, and differentiating the second function a to the power of minus x square upon 4a square t, this gives e to the power of minus x square upon 4a square t. And again minus of x square upon 4a square t differentiating with respect to t, this gives here once again minus of x square upon 4a square is taking constant, and 1 by t differentiating with respect to t here, this is 1 by of t, we have to take this is e to the power of minus 1, and when we have to differentiating with respect to t to the power minus 1, this gives minus of 1 minus t to the power of minus 2, and this gives minus 1 upon t to the power of 2. Using the formula here, del upon del x to the power xn is given by nx and minus of 1. So we have to writing here minus of 1 upon of t square, and again here is the second function, we have to writing here plus of e to the power of minus of x square upon 4a square t, and again the differentiating the second function t to the power of minus 1 by 2, this gives when we have to differentiating here, let's suppose this is t to the power of minus 1 by 2, and using the formula xn and nx and minus of 1, this gives minus of 1 by 2 and t to the power of minus 3 by 2, and in the last we have to writing here minus of 1 by 2 into t to the power of 3 by 2. Here we have to put minus of 1 upon 2 into t to the power of 3 by 2, and from here we have to, once again we have to writing del v upon del t is equal to, a is taking outside here, t to the power of minus 1 by 2 and e to the power of minus of x square upon 4a square into t, and here minus minus is plus, this gives into x square upon 4a square into t square, and here is minus, so we have to writing here minus of 1 upon of 2 into 2t into t to the power of 3 by 2 into e to the power of minus of x square upon 4a square into t, and from here we have to take common del v upon del t. Taking common here once again, we can also write this equation once again, t to the power of minus 1 by 2 is taken to denominator. This gives t to the power of 1 by 2, and 1 by 2 plus of 2, 1 by 2 plus of 2, this gives 5. Once again, 1 by 2 plus of 2, this gives 5 by 2. So this becomes e to the power of minus of x square upon 4a square into t into x square upon 4a square and t to the power of 5 by 2. T to the power of minus 1 by 2 is taken to denominator, and here is minus of 1 upon of 2 into t to the power of 3 by 2 into e to the power of minus x square upon 4a square into t. And from here we have to take common del v upon del t is equal to a, and we have to taking common first here e to the power of minus x square upon 4a square into t. Here is also present e to the power of minus x square upon 4a square into t, and here is also present e to the power of minus x square upon 4a square into t. And one more we have to take common, this is 1 upon of 2 and t to the power of 3 by 2. Then remaining present in the bracket here x square upon, here is we have to take 2 into t to the power 3 by 2 is taking common. Then here this gives 2a square into t, and here is minus of 1. Let this equation second. When we have to multiply t 3 by 2 plus of 1, second we have to check here, this gives 5 by 2. This equation 2, and further we have to solve once again. We have to show that we have to find del v upon del t, and further we have to find equation 1 partially differentiating with respect to x and treating t as a constant. Then we have to get here del v upon del x, and this gives here is a sub a t to the power of minus 1 by 2 is taking constant, only the function of x is e to the power of minus of x square upon 4a square t. This gives a into t to the power of minus 1 by 2 and e to the power of minus x square upon 4 square t differentiating with respect to x. This gives e to the power of minus x square upon 4a square into t, and again minus of x square upon 4a square t differentiating with respect to x. This gives minus of 2x upon 4a square t. This is the value of del v upon del x, and from here we have to take common del v upon del x, and we have to taking common once again. We have to take common minus of 2 minus of, once again 2 2s are 4, we have to cancel out the terms, and this gives minus of 1 upon of, we have to taking common from here, this is a and t to the power of minus 1 by 2 into 2a square into t is taking outside. Then the remaining is here x into e to the power of minus of x square upon 4a square into t. We can also take a minus common here, and further we have to differentiating del v upon del x, again differentiating with respect to x, treating t as a constant. This gives del 2v upon del x square, and here is minus of a into t to the power of minus 1 by 2 is upon 2a square into t is taking out constant here, and using the formula, this is the first function and this is the second function. First function is taking outside and second function differentiating with respect to x. This gives e to the power of minus of x square upon 4a square into t, and again minus of x square upon 4a square into 2 differentiating with respect to x. This gives minus of 2x upon 4a square t, and plus of the second function is e to the power of minus of x square upon 4a square into t, and the first function differentiating with respect to x, this gives 1. And from here we can also take common once again. We have to take common from here del 2v upon del x square. Here is minus of a into t to the power of minus 1 by 2 upon 2a square into t. We can also write t to the power of minus 1 by 2 is taken the denominator. This gives 1 by 2 plus of 1. This is 3 by 2. This is t to the power of 3 by 2. And we have to take common from here once again. We can also cancel out 2 2s are 4. And this gives, we have to take common once again, x square. We have to take common e to the power of minus of x square upon 4a square into t is take count from here. This gives, here in the remaining x into x is x square, and here is x square upon 2a square into t, and here is, once again, here is minus is already present here, minus and plus of 1. This minus multiplied with this bracket, this gives del 2v upon del x square, and here is a upon 2a square into t to the power of 3 by 2 into e to the power of minus of x square upon 4a square t, and minus is multiplied with this gives plus of x square, and here is minus of 1. So we have to write here once again, this is plus of x square upon 2a square into t and minus of 1. And using the equation 2, using equation 2, we have to put the value of a into e to the power of minus of x square upon 4a square into t into 1 upon of 2 to the power 3 by 2, and bracket here x square upon 2a square upon t minus of 1. In place of this, from equation second, we have to put here 1 by of a del 2v upon del x square. Once again, a is also present here, is also include. In place of this function, here we have to put del v upon, then remaining once again 1 upon of a square, and in this portion we have to put the value of, from equation 2, del v upon del t. And we can also write this is a square into del 2v upon del x square is equal to del v upon del t. This is the required solution of the given problem. Thank you class and thank you for watching.